So in this class, let us understand uh, one more model in chi-square test. It's a test for independence of attributes. Just look at the problem. From the adult male population of four large cities, random samples of sizes given below were taken and the number of married and single men recorded. Can we say that the proportion of married men is same in all cities? Just decode the problem. There are four cities A, B, C, D. In city A, it is collected total number of male population in the city A, that is 169. So in city A, out of 169 males, 137 males are already married. So 32 are unmarried. Like that, in city B, total male population is 221. Out of 221, 164 males are married, 57 are unmarried. I mean single. That is how the data is partitioned, tabulated properly. How many males are married, how many males are singles. So it is a clear classification between the male population from each city, how many are married, how many are not. So vertically totals are being given, horizontally totals are also given. Remember the data in I put yellow color to the grand total. Okay, that is a grand total. Now let us start working out this problem. Start with aim. What is the aim? To apply chi-square test for independence of attributes to the given data, right? Method and formulae. Okay, so chi-square calculated value can be obtained by using the summation OI minus EI square divided by EI. Okay, OIs are nothing but observed values of frequencies. EIs are expected values or frequencies, right? Give a proper color. Okay. Next, calculation. Okay, so start with null hypothesis H naught. And what is H naught? So actually, what is the question? Can we say that proportion of married men is same in all cities? So proportion of married men in a city A, B, C, D is equal or not? So we assume proportion of married men is same in all cities, that is A, B, C, D. So in city A, B, C, D, proportion of married men is same. That is what our assumption and the basic null hypothesis. And alternative hypothesis. copying and pasting. Wait, wait, right. Same, same statement, but contrast statement is not same. So proportion of married men is not same in all cities. That is A, B, C, D. That is what alternative hypothesis. Okay. Level of significance. Assuming alpha is 5%. 5%. Okay. Let us start working out this problem. Let us try to compute this problem. Let us look at the table first. This is a second version of a chi-square test. So actually, basically, from each city, we have the data regarding married men and singles. 137, 32, 164, 57, 152, 56, 147, 35. So these are the observations in a proper tabulated form. Okay, 137 is the observed frequency, 164 is the observed frequency, 152 is the observed frequency, 147 is the observed frequency, 32, 57, 56, 35. All these are observed frequencies. They so we have to compute expected value to each and observed frequency or observed value. So ప్రతి వాల్యూకి ఒక ఎక్స్పెక్టెడ్ వాల్యూని ముందు కంప్యూట్ చేయాలి. దట్ ఈస్ వాట్ అవర్ జాబ్ నౌ. So let us write first one by one the values are 137. So for 137 we need expected value. So we have to get the expected value for 137. That is our job here. So 137 is the first observation. So for first observation, what is the expected value? So it is computed as look at the 137 last total, the corresponding horizontal. Look at the horizontal way. Last subtotal is 600. So last value is 600. 137 vertically, look at the total 169. So for 137 last total is 600, vertically the total is 116. So 600 into 169 divided by some grand total, then you will get expected value for 137. So last value, vertically last value, multiply both these values and divide with the grand total. So this is what 600 into 169 divided by 780. This then you will get the final value. Simply you see it is 130 if you calculate. Next, next 164. We need expected value to the next number. E of 164. 164. Last value is 600. Vertically 164. The total is 221. Grand total is 780. So 600 into 221 divided by 780. Okay, and that is 170. Next value is 152. So last value is 600. Vertically the total is 208. Grand total is 780. Now we need E152. Last value is 600. Vertically the total is 208. Total divided by 780. And the value is 160. Okay, like that. For 147, E E147. Last value is 600. Vertically the total is 182. Grand total is 780. This will be 140. Okay, next four values are there: 32, 57, 56, 35. So 32, let us find out expected frequency for 32. E of 32. E of 32. Last value is 180, vertically 169. 180, 169 divided by grand value. This will be how much it is. Let us calculate. 180 into 169 divided by 780. So the value is 39. 39. So next value is E57. E57. Corresponding total value is 180. Here vertically the value is 221 divided by 780. Okay, and the value is 51. Let us check. 180 into 221 divided by 780. Is it right? 57. 180 into 221. 221 into 180 divided by 780. So the value is 51. Right. Next value. E of 56. Corresponding value is 180. Vertically the total is 208 divided by 780, and the value is 48. Next, E of 35. Last value is 180. Vertically the value is 182. Grand total, and the final value is 42. 42. 180 into 182 divided by 780. 42. So now we have all the values of uh, all the expected frequencies obtained by calculating using a small logic. Now let us prepare chi-square table, then go for testing it. How many observations are there? 1, 2, 3, 4. 1, 2, 3, 4. So 8 observations are there. We need 8 rows. The first one is let us write serial 1, 2, 3, 4, 5, 6, 7, 8. Okay. OI observed frequency set, expected frequency set. Right. Let us write the observations first. So 137, 164, 152, 147. So I'm just rewriting the same observations. The first one is 137, and the corresponding expected frequency is 130. So for 137 expected frequency is 130. Second observation 164, and its expected frequency is 170. So 164, 170, 152, 160. Third observation. Fourth one is 147. For 147, the expected frequency obtained is 140. 147. Calculated expected frequency is 140. And for 32, the value is 39. For 57, it is 51. 56, 48. 35, 42. Okay, 35, 42. Let us calculate the remaining columns. O minus EI, and that is 7. 7 square 40. First, prepare first column. Third, this column. 137 minus 137. 160 is 7 minus 170, that is minus 3. Next, 152 minus 160, that is minus 8. Next, plus 7. Next, minus 7. Next, plus 7. Next, plus 8. Next, minus 7. Okay, 49, 9, 64, 49, 49, 49, 64, 49. Calculate the last column. 49 divided by 130. This is 0.377. Next, 9 divided by 170. 9 divided by 170, that is 0.05. Next, 64 divided by 160, and that is 0.4. Next, 49 divided by 140, that is 0.35. Next, 49 divided by 39, 1.25. Next, 49 divided by 51, that is 0. That is 49 divided by 51, 0.96. 64 divided by 48, 1.33. Last, 49 divided by 42, 1.16. Okay, 9 divided by 167. Okay, let's just sum up all these values. Chi-square calculator. Sum of all these values, we will get the total chi-square value, that is 0.377, 0.377 plus 0.05 plus 0.4 plus 0.35 plus 1.25 plus 0.96 plus 1.33 plus 1.16. So the final value is 5.877. So chi-square value obtained, calculated value is 5.877. Just write chi-square calculated value is 5.877. Chi-square tabulated value at 5% level for So here, this is chi-square second model. Here, we check the tabulated value at degrees of freedom, but not at n minus 1. Here, uh, the data is tabulated in a proper way. Look at married and single. Two columns are there. How many columns are there? Two columns. How many rows are there? Four cities. A, B, C, D, four. So number of rows minus one into number of columns minus one. So two rows, four columns. So chi-square tabulated value will be checked at 5% level for 2 minus 1, number of rows minus 1 into number of columns minus 1. That is 2 minus 1 into 4 minus 1, 1 into 3, 3 degrees of freedom. And the value is 7.815. 7.815. Make a comparison now. So 5.877 is less than 7.815. That means chi-square cal value is less than chi-square tab value. That means H naught is accepted. H1 is rejected. Thus, so what is the null hypothesis? Proportion of married men is same in all cities, that is ABCD. Just replace and just copy and paste here. Thus, the proportion of married men is same in all cities, that in ABCD. Okay, so proper finishing is important to the problem. So write inference. Write inference. So in inference, first mention what the chi-square calculated value so far obtained. Next, chi-square tabulated value, and it is 7.815, and the result is H naught is the outcome, H1 is rejected, the conclusion part. Yes. So chi-square calculated value obtained is 5.877, tabulated value 7.815. H naught, the result of H naught is accepted, H1 is rejected, and therefore it is concluded that the proportion of married men is same in all cities. So four cities data with married and unmarried men data is given, and respective totals are also given. Grand total is also computed. It is everything is done in the table, but in other cases, if the data is given for cities just like highlight up to highlighted uh, cells, cities A B C D married and single, then we are required to compute first the subtotals, add one more column, add one more row, compute row wise totals and column wise totals, and also compute grand total. Okay, whenever the data is given in a tabulated form, remember that it is chi-square second model. uh, we have to apply independence of attributes, compute totals. So whatever the data is given, that is observed frequencies. For each and individual observed frequency, we are required to calculate expected frequencies using the same logic. Corresponding total into corresponding total, horizontal and vertical, divided by grand total. For each and individual cell, we just do it to get the expected value first. Start with the problem with A, method and formulae, calculation, and computation of expected frequencies first, and use as usual chi-square table, just proper finishing. and make a comparison whenever calculated value is less than the tabulated value, and we have every right to accept our null hypothesis and reject alternative hypothesis and rewrite the same in the inference. So four important stages, work out the problem using these four stages. That is very good. Okay.